So let's take a look at a couple of problems right here. The first question is from your textbook, page 364, number 8. A spec for the length of an auto part at Adams Metal Fabricating is 15.0 plus minus 1.75 centimeters. It costs $65 to scrap a part. Determine the Taguchi loss function, then determine the expected loss if the process mean is found to be 15.03 with a variance of 0.65 centimeters square. So if you remember, Taguchi loss function help us estimate expected loss given a quality dimension. Okay, so in number A's case, T is equal to 15.0. That is our quality dimension target. Okay, and then your lower spec limit is 15.0 minus 1.75. Oops, 1.75. And your upper specification limit is 15.0 plus 1.75. This is the range of tolerance. Okay, but when you exceed the spec limit, your penalty is $65. So based on this information, we can actually solve the first question, which is determine the Taguchi loss function. So if you remember, the general format of Taguchi loss function is Lx, loss at dimension x, that's what it says, is equal to k multiplied by the deviation, right? Square. So x is whatever dimension you'd like to use to calculate the potential loss. Okay, and t is the target, which is 15.0. So if you square it, multiply with the cost constant k, that is the Taguchi loss function. So in this case, the question is asking determine the loss function. And usually x and t are known, but we don't know what the k is. So when it says determine the Taguchi loss function, it really means to let us calculate what's the value of k. Okay? Because once k is known, whatever quality dimension you have, we can calculate its expected loss. So let's take a look. So it's telling us it will incur $65, right? $65 with k, and if you are deviating from the spec limit of 1.75. Okay, look at this thing closely if you need more time to think what this means. X minus t is a deviation from the target. Okay, 1.75 is the amount of deviation we're allowing, right? And then penalty happens after 1.75. So therefore we can write the loss function in this fashion. Only thing that is not known is actually k. So k is equal to 1.75 squared divided by 65. So in this case, k has a really small value. Let me see if this calculation is correct, okay? Okay. I think I flipped. I'm sorry. I should say 65 divided by 1.75 squared. So it's 21.2245. So your Taguchi loss function can be written as any dimension x is equal to 21.2245 x minus t square. Okay, this is your Taguchi loss function. And then if you'd like to evaluate any value of x, say what is the expected loss for a part with 17 centimeter. Okay, this is not part of the problem, I'm just making this up, okay? So now you have a new quality dimension you'd like to evaluate, which is 17.59 centimeter, and you can say 17 K is 212245. This is the same constant we're using here. And X is 1759 minus 15. You square it. This is the potential loss, expected loss at the quality dimension 17.59. Okay, so we solved question 1, question number 2. And the last question is determine the expected loss if the process mean is found to be 15.03 with a variance of 0.65 centimeter squared. So expected loss with let me see, $65. Okay, if you remember, there is a different way to utilize the Taguchi loss function, which is relying on the process variance and the average deviation. So in this case, we're no longer evaluating single component loss, but we're evaluating the expected loss of overall process. Okay, so if you look at the question carefully, it is asking us to evaluate the process instead of a single component has quality dimension of X, like we did in here. Okay, we're evaluating expected loss of a process, and this was written known as cost constant K with a variance plus deviation squared. Okay, deviation squared is the difference in mean. Okay, let me tell what that is. EL. The K is known as 212245. It won't change. And it told us what is the variance already, so we don't have to calculate anymore. And variance plus the mean difference. So mean difference, or the average deviation, here in this case is 15.03 minus 15 square. Okay, look at here carefully. So it provided us with a variance so that we don't have to square it, because variance already is something squared. And this is the mean difference, or the average deviation, or expected deviation. All these terms being used interchangeably. And 15.03, the current process, and the target 15. The difference, the mean difference here is the D. Okay, we square it. We got the result, 13.815. So based on the description of the process, the expected loss of the overall process is actually $13.815. Okay, so this solves problem number 8. And let's move on to take a look at the problem number 13 real quick. Okay, the computer chip designed by the Kikuchi has a specification for the distance between two adjacent pins of 2 mm plus minus 0.002 mm. The loss due to a defective chip is $4. A sample of 25 chips was drawn from the production process, and the results in millimeters can be found in data. So in this case, I think the first question is telling us to evaluate the Taguchi loss function, telling us to get the value of K. The second one is letting us evaluate the process, not based on the descriptive statistics like problem number 8, rather letting us evaluate from a sample data it has drawn from the process. Okay, anyway, let's take a look at the question number 8 first. Compute the value of K. So let's take a look. No, I'm not gonna. Okay. So again, the loss at dimension X equals to K X minus T squared. It's hinting it is actually $4. We don't know K. The deviation is 0.002. Okay, So what you can do here is k equal to 4 divided by 002 squared. So I don't really like this. So it's written in the form of what? Yeah, this is this is 1 million actually. This is moving the decimal point to the 6 point forward. It has turned to 1 million. So k here equals to 1 million. Okay, so this is a cost constant. So you can say, therefore, the Taguchi loss function for this process is again x minus t. So this kind of completes the problem number A. And what is the expected loss from this process based on the sample data? So all the data is being attached in the Blackboard. Somebody left me a message here. And quality, let's take a look. Main area. And we have data here. So chapter 7 data is here. So let's take a look, open it up. Let's go all the way to problem 13. Okay, problem 13. So, second question. We need to know the variance and D, because expected loss equal to k variance plus D squared, right? And because k it's known as a 1 million, we just need to get the variance of these guys. So if you remember, the variance, just simply variance of sample. Okay, let's get all the sample here. Ooh, this is the variance? Yeah, variance is actually quite small. Again, I don't like it. So variance 0, 0, 0, 0, 0, 1, 0, 7, 6, 7. And the D, right? D is actually D is actually the difference between the average of this process. So the average is actually 2. So 2 minus 2 equals to 0. You square it, we still get a 0. So this is actually our expected loss from this process. Look at this formula carefully, right? Variance we've obtained using the variance formula here. And so the average here we obtained, excuse me, using average formula. And then this 2 is the t, the value of t. Okay, so here this is a mean difference. We squared it, and this is the result. So this concludes exercise 8 and 13. If you have a question, please let me know.